All right, so we're talking about graphs. You'll need your paper, your notes ready to go. All right. Graph of sine of x. It's all about graphing today and the ramifications of stretching and shrinking and flipping them and all that stuff. Amplitude. We'll have a lot of new words today. So to really understand this, you need to understand. Excuse me. Okay. Don't talk right now. You need to understand how to number this in a different way than we're used to. What you're used to right now is, if I said this was pi over 2, you'd be like, yeah, you told me that before. That's pi, yeah. Okay, so you go around, your first notch you hit is pi over 2, then you get to pi, and then what do you get to after that? Do you remember this one? 3 pi over 2. Ugh, that got weird. And then this, when you go around one last notch, would be 2 pi. That's what you're used to now. What we need to get to now is to say if this is 0, right here, and it's going to end at 2 pi, then the first notch right here, that'd be pi over 2. The next notch would be pi. The next notch would be 3 pi over 2. And the last one is 2 pi. Does that make sense to you? So we're just numbering across now instead of numbering around a circle. All right, you want to copy this one down, like letter for letter, word for word. This is like really important because this is like the foundation of all the graphing stuff that we're going to do. Because it all is about sine. In fact, cosine isn't even really cosine. It's just sine except shifted. It's all about sine. They're called sinusoidals because they're all about sine. I'll show you more about that in a second. I'm just numbering backwards. Negative pi over 2. Negative pi. Negative 3 pi over 2. And negative 2 pi. Now, do you get that sine just oscillates back and forth? It's a wave. It goes up, down, up, down, up, down. Okay, where does it start? Does sine start at 0? Yes, it does. Sine starts right here at 0. And sine goes up until it hits 1. And then it comes back down again, hits 0. And then it stays in the negatives for a while. And then it comes back up and hits 0 again. That's one complete cycle. That's also known as a period. Okay, it's the period of this thing is how long does it take for it to complete. I have a cat, and it's pregnant, and I don't know what the gestation period is on cats. Okay, but there's a normal length of time. Anybody have a clue what it is for cats? I know for an elephant, it's more than a year. Seems like the bigger the things are, the longer they stay in there, hatching, so to speak. Okay. Human beings, we're talking 9 months. Exactly how many weeks? Anybody know exactly the number of weeks? 40-something weeks. Okay, sounds about right. 42-ish. And if you're talking about small things, they usually get born a lot more quickly. And so I'm thinking it's like three months. Yeah, something like that. I'm thinking 12 weeks. Maybe? Oh, you Googled it. Thank you. 64 days? Really? Awesome. Okay, 64 days. That's cool to know. So about 2 months. All right. Well, sine completes its cycle in 2 pi. Think of this as time. It's almost like a time thing because normally it's time across the bottom. All right. Okay, and of course, if I go backwards, it's not too hard to extrapolate what it would do. It would go down here, and then it would come up, and then it would go all the way up, and then it would come back down again. And so there we go. There's sine going both directions. Do you get that I just did sine from negative 2 pi all the way to 2 pi? That's the interval over which I graphed sine. From negative 2 pi to 2 pi. All right. Now, the very first problem in the worksheet's pretty easy. They're just going to ask you some things like, in that interval, what was the y-intercept? It's not very hard. It touches the y-axis only once, and touches it where? 0, 0. So the answer is 0, 0, or you could have said 0 as the y-intercept. Okay? And how about the x-intercepts? A lot more of those, though, right? Okay, so the x-intercepts would be here, 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 and here. And so x-intercepts are where y is 0. So if I wanted to say what this x-intercept was right there, I would say it was at something comma something, And if it's an x-intercept, y is 0. Negative pi comma 0. That's that spot right there. All right? Yes, ma'am. Good question. Nope. The y-axis is not numbered the same way. The y-axis is simple numbers. 1, and in this case, these bars are so far apart, it's kind of freaking me out. But that black bar right there, I think, should be up a little higher so that it's like the same height as the other one. So try to ignore that one. Anyway, this should be at 1 and negative 1. So that's at 1, that's at negative 1. So you'd think that they would number it the same way, but they don't. All right. So there's your graph of sine, and cosine would look a lot alike. I'm just going to back up to where I had the graph all numbered, but so if I were you, I'd make another one like this. Don't try to put them on the same graph, or it'll make this loop that together they look kind of like the DNA strand or something. But you know what I mean? Like if you do cosine on here, it's going to be a little confusing because it starts here and it goes down, ends up back up again, over here, goes down. Anyway, it would look like that, and they kind of intertwine so much that it's better to just start over. I can do that by hitting the back button, and I'm going to do it. There. Okay. So to graph cosine, I'm going to change this to cos. Cosine is the exact same thing as sine, except it's been shifted a little bit. I think you'll see that in a second. But I'm going to start by just graphing it more the normal way. Cosine starts at 1, goes down, comes back up again, and it touches here and here at 1, touches here and here at my x-intercepts. And if I keep the pattern going, it's going to go like this. And it just keeps oscillating back and forth and back and forth and back and forth. Okay? That's the graph of cosine. And sometimes it's positive, sometimes it's negative. And I showed you that on the circle graph too. That ASTC thing, all students take calc. It was a reminder that sometimes these functions are negative, sometimes they're positive. Thankfully, we don't have to teach tangent today. That's a completely different kind of graph. It's not a wave at all. Well, it's kind of a wave, but it's a totally different kind of wave. We'll do that some other completely different day. All right. So what do you really have to know about this? It boils down to the sunburst there, this big function. This is like the general form of a sinusoidal. Kind of like the first time you learned, y minus y sub 1 equals m times x minus x sub 1. Or maybe the first time you use a quadratic formula, it's got all the general letters in there. Okay, write this one down, and I'll tell you what each little part means. A sine of parentheses bx plus c parentheses plus d. This one is worthy. There's a lot of noteworthy stuff here. Like, you got to have this thing memorized for the test, and you got to know what each part means. The A right here, if you take the absolute value of that, that's your amplitude. If you've ever heard of that, but amplitude basically means how high the waves go. Okay? Amplitude. And again, it's the absolute value of that front number. So in other words, if there's a negative on there, making the whole thing flip, then it doesn't affect the amplitude. It doesn't affect the wave height. When I was out on the ocean, I got a chance, to go for that long weekend thing, and I went down to St. John, and we had the chance to go out in this little boat. When we were going on the waves, there were some big ones out there, and it was kind of cool to see, these waves where you couldn't actually, when you get down in the trough, you couldn't see very well because you're looking up at this wave. And I was wondering, I wonder how people in like the ocean business, the sailors, measure their waves. I know in math how we measure them, but do they measure them from the bottom to the top? And they say it's like an 8-foot wave. Do you think they measure it all the way from the trough to the top? I don't know. I don't think so. Anybody actually a sailor in here, or have been sailing, or okay? How do they measure it with surfing? Do you know? It is. Well, I can tell you this: in math, when we measure a wave, the amplitude isn't from here to here. It's half of that. It's from here to the top, or from here to the bottom. It's half of the total. So in other words, if you measured and there was 8 feet in between here and here, then we'd say the amplitude of the wave would be 4 feet. If you think of it this way, like the ocean, if you could just instantly make the ocean go flat, just go back to normal, okay? Then the ocean would be right here, right? And then it's how high the wave would have been compared to where the sea normally would be. That makes sense? So there's this height right here. That's the amplitude. All right, now on the sine function, how high does that go? Let's look back here for a second. You notice I went only up to there. Sine has an amplitude of 1. Notice the total distance between here and here would be 2, but we divide it in half. So sine has an amplitude of 1. All right. So back to this. So sine's normal amplitude, the normal number you'd have right there, would be a 1. All right, next thing, the period. The length of one full cycle of the wave. And it's 2 pi over the absolute value of b. All right, 2 pi over b. Usually b doesn't have any negative on it, so I usually just shortcut that and say 2 pi over b. I know you're thinking, how could this be that important? It is. We use this one more than anything else. Period's 2 pi over b. You're going to use it over and over and over, so write it down. Period is 2 pi over b. Yes, sir. It doesn't. To get the period, you have to always take 2 pi and then divide it by that b number. So the b is the closest thing we have to the period, but it's not the period. So the period will be 2 pi. It's kind of like your standard period. And if there's a b number here, if there isn't a b number, then it's like b is 1. So we take 2 pi divided by 1 is 2 pi. And if there is a b number there, it changes the period from 2 pi. So you just kind of start with 2 pi, and then you divide by whatever b is. Okay? All right, that's how you find out the period of the sinusoidal. And then the next part is this c here. And that has to do with the frequency and the phase shift. All right, the frequency is, I'm wrong, it's not the frequency, it's the phase shift. Sorry, c is just the phase shift. But I have another thing on my chart here I have to explain to you, which is frequency. And basically it's how, if you have a wave that goes like this, that's different, of course, than a wave that's like long and flat. Okay? If you're talking sound waves, when you have the elephants talking to each other, it goes something like this. They have really long waves, and those waves can travel long distances through the ground. And if you have the hummingbirds talking to each other, extremely high noises. But hummingbirds can probably only talk to each other about 10 feet apart. And because those waves break down over time, whereas the elephants can talk to each other 12 miles apart. It's just insane. They can't even see each other so far away when they can talk to each other, because their sound waves actually pick up in the ground and travel to the ground. All right, so the frequency is how tight those waves are. And the way you get that is it's the reciprocal of the period. So if the period was this, the reciprocal of that is b over 2 pi. That one we don't use very much. I'm being honest with you. Sometimes we need these things, sometimes we don't. Frequency is not one you're going to use a lot. But period, you can use all the time. The 2 pi over b one, really important. This one's less important. All right, this phase shift thing's going to come up, more than the frequency anyway. And phase shift is c over b. I'm going to call it Vs for phase shift is c divided by b. Your next test, full of this stuff. Here's an equation. What's its phase shift? What's its amplitude? Amplitude's easy, it's just the number in front. Except that it should tell you that. What's its period? 2 pi over b. Yes? Let me think. Yes, it is. Now, again, I almost never have a situation where b is negative, but if it ever was, yes. You strip out, and same with the amplitude, you strip it out. Now on the phase shift, You kind of could say it's absolute value, but what we're going to do with the sine is it's going to move right if it's negative and left if it's positive. The exact same rules as when you had those like quadratics where it moves left or right and stuff. So the negatives are kind of something we set aside. Yes. How do you find B? I'll show you that. B is that. It's a number, and it'll be in the equation. I'll show you. Just for right now, you need to know the formula. I'll show you practical examples in just a minute. All right, so I'm trying to just walk you through each step of the formula. We got the B part. We talked about the C, which is the phase shift. And the last part is D, which is the vertical shift. Not stretch, vertical shift. The whole thing can be moved up. It's like if I took this sine wave right here, I'll draw it in green, and I wanted to do like +3, I could grab it, move it up 3, and move the whole wave up. All right. So if we relate this back to something you're used to, it's a lot like this. Do you remember when we had these and it was a parabola? And that made it 2 times taller. And that made it flip up, down, flip. And this made it move 3 to the right. And this made the whole thing move up 7. Does that ring a bell? So now what you're going to have is things like this. And this means the whole graph that was going like this is going to have to flip up, down, and start going like that. Okay? This, too, would mean the whole graph that used to be going like this is going to go twice as tall and twice as low. Okay? And this part right here has to do with the period, which, remember how before, if I had a number like here, there was like a 6 here, it would mean that the whole thing got not 6 times wider, but 6 times narrower. This affects the frequency. It makes your graph that was like this be more like this. Okay, that number does that. This is the phase shift. It's just a shift like this. That's 3 to the right. This is pi to the right. The phase shift, technically, if you remember the little formula, was C over B. So it's that divided by that. So pi over 3 is how far I shifted to the right or left. Why is it pi over 3? Go back to the very beginning graph. Remember these? That's how far we're going to shift things, like pi over 2. It's a right-left thing now. All right, and this thing would mean move the whole sine graph up 7. So if the sine graph used to be like this, I grab it and I move it up 7, way up there. Okay, that's kind of big picture what we're talking about here. So now, what would you actually be expected to do? I gotta straighten this out just for a second here. There we go. All right. If I just have plain old sine of x, what's its amplitude? 1. You can think of it as there's a 1 in front of it. Or you can just think of it as how high does it go? It goes up to 1, ends up going down to -1, and then it's back up to normal. Okay? What's the amplitude on that puppy? 2. What's the amplitude on this one? 1/3. That's all there is to it. Now, what does it actually do to it? Well, this is just normal sine. This is sine except twice as tall. So it goes up to twice as high as it used to. This is 1/3 as high as it used to, so it barely is rising at all. It's hard to draw that up one more time. Very flat. Okay? And this has 2 things going on. Flip, and what's that 2 make it? Twice as tall and a flip. All right, so you'd say it's a up-down flip, which would be a reflection over the x-axis. And then the 2 would mean it's a vertical stretch. It's twice as tall. All right. Find the period. I have a formula for that. Do you have the formula for that? Period is what? Close. 2 pi over b. Oh, I thought you said pi over b. Okay. 2 pi over b. So 2 pi over b, what's the period for this one then? Period of pi is 2 pi over, is there a b? Well, if there is a b, it's 1. So it's 2 pi over 1, which is just 2 pi. And that makes sense. Sine's period is 2 pi. So yay. All right, how about this one? This one doesn't make any sense at all. I'm going to rewrite it. Y equals sine of x over 3. And I'm amazed at how many kids don't get naturally. That's the same exact thing as saying sine of 1/3 x. Do you get that those two things are the exact same thing? X over 3 is the same exact thing as 1/3 x. But if you write it as 1/3 x, it's a lot easier to see that that's your b term. Okay, so what am I supposed to do? 2 pi over b, and b is 1/3. So it's 2 pi over 1/3. Now for that, you got a fraction and a fraction. Do you remember what to do? If you have 5 divided by 1/3, you go 5 times, flip the bottom one. So it'd be 15, right? Okay, so back to this one. If you can handle that, you can handle this. 2 pi times 3, which would be 6 pi. So its period used to be 2 pi, but now this has changed its period so that it's going to get over with in 6 pi instead of 2 pi, which means you stretched it out wider. And doesn't that make sense if it's 1/3 that it should actually get wider? Because it's so counterintuitive. All right. I want to take a second and just have you do the period on that. Remember, it's technically 2 pi over the absolute value of b. Almost lunchtime here, see if you can hang on. So hopefully you said 2 pi over absolute value of b. Absolute value of b would be the absolute value of -2, which would be 2. And if you cancel these, it would just be pi. Raise your hand if you had that one right. Okay, good. Now, here's the other part. The transformation. Do you get there's two things that are going to happen because of this? It's going to flip which way? Left, right, or up, down? When you're on the inside, that's left, right. So that's a left, right flip. And what's this 2? Is it going to make it twice as wide or half as wide? Half as wide. And if that makes sense, I hope it would make sense from in the context of sine normally goes like this and gets over with in 2 pi. But now we just figured out that the period would be 2 pi over 2, which would be pi. It means the whole thing has to get over with in pi. So to get the whole thing over with in pi now, it needs to scrunch down and needs to have the whole cycle done with by here. That's where pi is. So then I need to have it be like that. See how it just got scrunched down narrower? And now we'd have to flip left, right. That's correct. Oh, that really starts to blow your mind because if you flip this left, right, it's going to look like you flipped it up, down. Very soon. Very soon. All right. I think I can almost be done, so let's just get a little bit farther. Actually, it is lunchtime. Go to lunch. Go. All right, so a reminder about frequency. Frequency is the flip of, the reciprocal of, the period. The period is 2 pi over b, so this must be b over 2 pi. Okay, so frequency is b over 2 pi. 2 pi. So when I get to this one and it says find the frequency of, we need to do b over 2 pi. That, of course, begs the question, what the heck is b? Because I already know what 2 pi is. 2 pi is 2 pi. What's b? Well, that right there, 2x over 3, do you get that that means 2/3 x? It's the same exact thing. So then what's b? 2/3. So if I'm going to do b over 2 pi, I'm going to do 2/3 over 2 pi. And then when you flip, you do the reciprocal dealy bob, you want to do 2/3 stays the same. We don't flip that. We flip this part. Times by 1 over 2 pi. Okay, and so now we've got 2 over 6 pi, which makes it 1 over 3 pi, also known as pi over 3. See what just happened there? Okay, yes sir. Nope. Wait a minute, did I do something wrong there? I might have done something wrong there. The last little pi over 3, I think I goofed it up. 1/3. 1 over 3 pi, I was right so far. Let me make sure here. Is that pi on the bottom? I think it is. I think it's 1. I think I've got it right now. There, that's the frequency of it. All right. Now, if we find a phase shift, the phase shift is the next kind, which is, there's a little formula for that. There's an app for that. Look in your notes. What's the formula for C over B? All right. So we just got us do C over B. Well, what's C? That's C over B. If there's nothing there, what is there then? 1. So it's really, what's pi over 2 over 1. So that's really pi over 2. Now, if you think about it, it's really not that complicated. What's the phase shift? It's the shift. How far does it shift? It shifts that far. There's just nothing to change that because there's no number in front. If there'd been a number in front there, then we'd have had to deal with it, but there wasn't, so that's it. So the phase shift is that. And which way is it going to shift my graph, right or left? A little close there. Seems like it should be to the right. It's on the inside. It's counterintuitive. It should go left. Okay? So my whole sine graph, which would normally look like this, should go to the left. Pi over 2. Now, how far is a pi over 2? Pi over 2 is this spot. So that means from here to here is pi over 2. So I'm going to shift this thing 1 notch. There we go. All right, now, do you notice what just happened there? We just got cosine. Very good. Let me show that again. If this is sine, I'm going to draw it more carefully. Sine starts at 0 and goes up. Comes up at 1. Down at 0. Up at 1. Back up to 0. If I shift that exactly pi over 2 this far, then that is cosine. It's just that we normally draw the cosine from here to here, so I just need to finish the graph. Can you see now that from here to here it is cosine? So sine and cosine are the same exact thing except shifted. You've shifted that far. So sine, when it's shifted that far, becomes cosine. This one. Nope. The frequency is b over 2 pi. You don't have just a number that tells you the frequency. The frequency is based on 2 pi because, you know, the whole thing has to get over with normally by here, which is 2 pi. But if you're doing something on the inside, you're stretching it like left, right, and then you're messing with that. You're saying you're not going to get done at 2 pi like you normally would. You're going to either get done quicker than that, you'll have to have the whole cycle over with like quicker, like maybe the whole cycle's done in there. That's crunched it down. Or you stretch it out and have the whole cycle be like, take longer to complete. And it still has a full cycle, but it completes it like 4 pi or whatever. So the frequency has to do with the period. And again, it's this flip of the period. Period was 2 pi over b. Frequency is b over 2. If I have one like this, okay, sine of bx plus c and then plus d, that is the move the whole thing up part. It would be comparable to this. Here's a parabola, been moved up 5. Here's a sine graph, been moved up whatever d. No, it moves the whole thing up. Like picture this. Picture the U shape here. Here's a parabola. You get that in my typical parabola? Except what's this plus 3 do? Moves left 3. And then what's that plus 5 do? Moves the whole thing up 5. Same thing, except now we're not talking about parabolas. We're talking about sine graphs. So if this is my sine graph, normally it looks like this. And I do this to it. Maybe my graph looks like this. Sine of x plus 5. Then I just took the whole thing and moved it up 5. So I grabbed this whole thing, moved the whole thing up 5. Okay. Okay. I think that pretty much covers, except the exact same thing for cosine. I don't want to go through the exact same smartboard except for cosine. It's the exact same thing. I mean, it's still amplitudes in front. It's still the 2 pi over b tells me the period. How do you ever use c? That's for the phase shift. C over b, phase shift. Yes. And then this last thing, the d, is how far the whole thing gets moved up or down. Right? All right, so I don't think we need to go through a whole bunch of cosine examples. I want to do some of your homework with you. Here is your homework, and we'll start it together. Now, in some of the teachers' classes today, they are actually doing the graphing part. I don't want to because it felt like too much. It probably could have, many of you probably could have handled it, but I didn't feel like in my first hour class that I was ready to go that far with them. I think their brains would have exploded. So I wanted to stop and make sure, it really is important to me, the kids don't ever go home completely lost. You know, those kids are going to go home and a little bit lost, but I don't want it to be like a widespread, like most everybody went home saying, I have no idea what's going on. Don't like that. All right, so let's do the first problem together here. Number 1. First thing it says is, analyzing the graph of the sine function, suppose you have the graph of y equals sine of x. Well, I'll tell you, you're going to need to, at the margin at the top of your page, right above number 1, you need to make a big long graph that's sine. So start with having a big long xy axis like this. And we're going to have to graph sine all the way from negative 2 pi to 2 pi. You have it in your notes probably, but it'll be really good for you to practice it. We have a test on graphing soon. About a week from now or so. There's a test on graphing. So let's just have a practice of it on the top of your page. So if I'm going to graph sine, I need some other little intermediary marks in between here. This is negative pi. And then I'll use a different color, but here's pi over 2. And here's 3 pi over 2. And here's negative pi over 2. And here's negative 3 pi over 2. All these spots are really important. They're the key spots. Then when I graph sine, it starts at 0 and it goes up from here. Comes back down. Down to negative 1, comes back up. That's the one I hope you're already pretty familiar with. But now we have to continue it out. I'm going to do it with a dotted line. Make sure I do it right. There. So there's your graph between negative 2 pi and 2 pi. Why? Because that's what they ask about on A, B, C, and D. Okay, part A, what are the x-intercepts? Is there a question? Yes, sir. Part A, what are the x-intercepts? The x-intercepts are these spots. There, 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 and there. To make it an x-intercept, you need y to be 0. So here's all the spots. Negative 2 pi, comma, 0. Union with. Negative pi, comma, 0. Union with. 0, 0. Union with, etc. Just list all the x-intercepts like that. Remember, the x-intercepts are where it's y equals 0, so it's comma 0. All right, part B. Part B says, what is the y-intercept? The y-intercept is where x is 0. It's right there. It is 0, 0. Part C, where is the graph increasing? I'm going to do it in green. It's increasing right in that little zone right there. And just hold on. Is it increasing in that spot? Or? Okay, good. And okay, that's important. Then it says between negative pi and pi. Okay. So between here and here. So it is increasing right here, and that's the only spot it's increasing because it's limited to that little zone. If they allowed me to look over here, I could say it was increasing there, but I'm not supposed to look there. It's supposed to stay between here and here. So how do you write that? You'd say from here to there for these kind of things. What's the largest value? It just means what the highest it gets. 1. All right. Same idea for cosine. The answers aren't the same, though. You'll have to make your own picture like this. Unless you can just do it in your head, which is going to be tough. But it really wouldn't be that hard to just make it. But it is up to you. It doesn't say you have to make the picture. So, Johnny, if you can do it in your head, no problem. Yeah, it doesn't require you to make one, so you can do it any way you want to. But I guess you might want to just sketch it like this. And on the same graph, and then you get, there. And then this wavy one here would be like cosine, and you can go through. Okay, but let me explain what I want you to do for the rest of the worksheet. First of all, it feels a little bit largish, and so I'm going to have you skip 13 and 14. That'll make it more reasonable. And the next thing is, for tonight's homework, I'm not going to require you to actually do the graphing part. So you're just going to have to do the other parts that it asks you about. Okay, so don't like cross off the graphs. We'll do them eventually. You can skip problem 13 and 14 completely. But for the other ones, just do what it says in the directions, which is state the amplitude and the period and describe the transformations in the correct order. The only thing we're not doing is, lastly, graph one period of the function. Okay, we're not going to do the actual graph. So for number 3, for instance, it wants us to tell the amplitude. It wants us to tell what the period would be. And it wants the transformations. Like that. Okay, so for number 3, what is the amplitude? Very simple answer. What is it? 2. The number that's in front. It says y equals 2 sine x. That's the amplitude. Okay, what's the period? Oh, gotta have a formula. What's the formula for that, puppy? 2 pi over b. Technically 2 pi over the absolute value of b. And 2 pi over, what is b? 1. So it's 2 pi. The amplitude is 2, and the period is 2 pi. And is there any transformations? Yeah, this one isn't too hard. You just have to do some simple thing to it. What? Stretch. Vert. Stretch. Factor 2. There we go. Now, actually graphing it, we'll save that for some other day. Probably tomorrow. All right, so the rest of the assignment is to go through the rest of this thing. There is some review. I'd say it's more important than ever to get your review done here, the 15 and 16, because this is kind of easy because I took off all the graphing part of it. We'll do that part tomorrow. So make sure you get 15 and 16 done. Very good review of what you learned in the last couple days. All right. That's all I got for you for now.